When agents don't have the right context, users have to keep repeating their preferences to get reliable behavior. Zep solves this by turning chat history and other user data into an intelligent knowledge graph that provides context to agents right when they need it. For example, this knowledge graph contains the preference that the user prefers 2 pumps of mocha syrup in their coffee. This knowledge graph is connected to this chatbot. So when the user tells the agent to order coffee, it automatically knows the user's preference. The rest of this video gives a high-level overview of how Zep works and then walks through how to get started using only 5 bits of code. Zep is a context engineering platform designed to make it easy to build more personalized and reliable agents. It allows streaming any kind of text data, such as conversations, business data, JSON, or unstructured text, representing the many different touchpoints a user might have with a business or product. Zep fuses this data into a unified knowledge graph, and this knowledge graph continuously grows as users interact with agents. If new data contradicts previous data, the outdated information is automatically marked as invalid. For example, if a user changes their coffee preference, the old preference becomes invalid, ensuring the agent always relies on the most current information. On top of the knowledge graph, Zep provides multiple retrieval and context assembly methods to help curate what information an agent receives. The most common approach uses the Zep context block. This context block is automatically generated and can be easily integrated into an agent's system prompt, enabling more personalized and contextually accurate responses. To get started, clone the code for this example from the provided GitHub repo and just follow the setup instructions in the README. The example includes a dashboard that allows creating new users, creating threads, comparing agent behavior with and without Zep, and viewing both the Zep context block and Zep latency measurements. Back to the code, the first 2 bits of Zep logic are creating the user and creating the thread when the respective buttons are clicked in the dashboard. In Zep, each end user must have a corresponding Zep user, which starts with an empty knowledge graph for storing that user's long-term memory. The remaining 3 bits of Zep logic are defined in this onReceive message function of the agent. First, when a message is received, the message is added to the Zep thread. Next, the Zep context block is retrieved, containing information from the knowledge graph that is most relevant to the user's message. The Zep context block is then inserted into the system prompt before response generation, ensuring the agent has access to the most relevant, up-to-date information so it can respond in a more personalized and helpful way. Once the agent's response is generated, it is also added to the Zep thread. That's all it takes to implement Zep. With this setup, user interactions continuously stream into the knowledge graph, and the most relevant context is automatically provided to the agent on every turn, resulting in more personalized, helpful, and accurate responses. This example shows how Zep enables agents to become more personalized and reliable through long-term memory. To explore further, clone the example repository and visit the Zep documentation to learn more about what Zep can do.